All right, so looking at this homework, I think the best way to probably start analyzing it is just to think about starting out by making a table. So I'm going to start here. I'm going to record my step number. And this one's asking us to analyze the number of squares. So in the other part of my table, I'm going to analyze the number of squares. So it looks like on step 1, I've got 1 square. So you can see that just in this picture here. On step 2, I've got 2 squares. On step 3, I've got 3 squares. On step 4, I've got 4 squares. So it looks like every time the step goes up, the squares go up. So if I start kind of making this pattern here, I would anticipate, so maybe +1 every step. Or if I look at this, the step number is equal to the number of squares. So if I kind of continue that pattern, I can see that that's a linear pattern. So there's my line. On this axis, I'd have my step number. And on this axis, I'd have my number of squares. Okay. So if I think about x as being my step number and y as being my number of squares, the equation for this would be that the number of squares, y, is equal to the step number x. So that would be a good equation to use, and I might say that y equals, if I plug in step 43, 43. And your reasoning could just be, kind of based on this here, that you observe that the step number equals the number of squares. Does this represent a function? So a function, definition of a function, is that for every x, okay, there is only one y. And that means it'll pass the vertical line test. So since the step number is equal to the number of squares, it will be a function. The answer is yes. And if we look at our graph, if I were to draw vertical lines here, none of these vertical lines are hitting the graph more than once. So I could say the graph passes the VLT, the vertical line test. Or for every x, there's only one y.